All right, so questions with, let's start with your homework. Were there any questions that came out of the carrier scene? Anything that was like, I don't get it? Yeah. Okay, so if I'm understanding, because there should be no difference on the Mac, so it's probably not a Mac PC, if I'm understanding your question correctly. So what you were seeing in the Unity editor was not lining up to what you were seeing in your folder? Is that the
No, it was like all the information was augmented. I don't know if
Oh, okay. Oh, it wasn't playing.
Yeah.
Yeah. Okay, so play mode wasn't working essentially. If I had to, okay, we might take a look. Yeah, at what you're running on. It could be that. My suggestion would be try it on a different system and see if you're getting the same issue. If we can narrow down what pathway to explore, that'll make it a little easier. So if you try it on these and you're having the same issue, then it's something probably in your Unity scene. If it's working fine, then it might be, okay, maybe you just don't have enough RAM, or maybe it's a graphics card thing, and then we can address that separately. Yeah, for sure. Yeah. All right, other questions? Anything else come from that? Yeah.
Not sure exactly how to explain this, but when you created the first person camera thing,
yeah, it's like a pod almost, like it's
pod, yeah, and then put it in front of the door.
Mm-hmm.
It had like this little speaker next to it that seemed like it was, I guess it's the audio, but it seemed like it was like, if I moved this speaker, then the pod moved. And I noticed that, it's hard to explain, but I noticed that like when the pod camera wasn't properly aligned with the door,
Okay.
the trigger didn't open both of the doors. Like at first I had the thing a little bit off to like slightly off to the right or something like that, and so when I tested it, it was like one door, just only one of the doors opened, but then so I was playing around with it, and then I like moved it a little slightly back over to the left, and then it worked. So it was like,
so it might have been having a collision error or something like that with the trigger.
It might have just.
It seemed like, I mean, is that camera connected to the trigger, or is it just literally showing the door?
Yeah, your. If I'm understanding your question correctly here, yes, your body. So that orb, as soon as it makes contact with that trigger, it should request that the door is open. So if it was off a little bit and it wasn't, although to only do one of them, that's curious. So should trigger both. Open that up real quick.
So that camera actually represents your body,
Right.
Mm-hmm.
As a first person.
Mm-hmm.
Like, you know,
I'm gonna open it up real quick. We'll take a look. I think I've got a saved version. Let's see. Mm-hmm. Trigger. See if I have a finished. And if we don't figure this out right on the spot. What I'll do is I'll pull up your particular file and take a look at it.
Okay.
See, I thought I
Yeah, I
maybe
was able
had some that was like.
fix it eventually, but it seemed like it was connected to where that camera was placed, which seemed weird to me. 'Cause it seems like when you move your perspective around, it should go through the trigger, right? No, regardless of where the starting point of that camera is.
Yeah, I thought I had one. I thought I had a file in here with the character already. There's my first person. There we go. Oh, this is okay. Part of this is because I updated this version anyway, so that's okay. Yeah, so what should happen? Let's find our doors, our animated doors here. So there's our trigger. There's our door. Okay, great. So without going through and like adding the script back and stuff, because I'm not gonna get a lot to get through today. So what should happen as your we got this trigger on. Yeah. So as this player, as its sphere, anywhere, if it hits the sphere in any way, it should trigger that reaction. So if it's off just a little bit, you might not get that reaction, that trigger happening. But what's curious to me is that you are still getting one door to interact.
Yeah.
So what we might do is take a peek at your file and see what you got.
Well, I did notice too that there was one of the doors had the automatically open box check. So that might have been why that happened.
Yeah.
But then it did seem.
Yeah, this needs to be undone for these.
Yeah, it did seem connected to where I placed that original camera. Like I have the trigger thing right in dead center, taking up that whole space. But it seemed like, if I shifted the camera, it actually
Yeah, let's see. Let's pull up your file. I want to take a look and see what you got going on.
Okay.
Because yeah, generally with this controller too, you're not going to want to shift the camera out of the group. So that might be some of the issue. So if you were shifting this separate and your player controller is still over here with the way that scripting is set up and you get these off, it might be causing some behavioral problems, shall we say. So you'll want to make sure if you're grabbing your first person controller that you're grabbing the group rather than the contents within the group. Because your colliders are going to be attached to the graphic. So that's probably, I'm guessing that's what the issue is. But we can take a look at it and see. Yeah. Yeah. So these two things will want to stay together. Okay. Yeah. All right. Cool. Any other outstanding questions? No? Okay. How about rollerball? How'd that go? You guys all got it complete? Any questions with that? No? Pretty straight. Yes, I bet. What did Michael have you guys do with that side of it? Oh, good. All right. So it was a good extension. Perfect. Okay. I like it. Yeah, I mean, we're sort of dancing around the code in here. But, you guys, for those of you who are not in the dev class, if you guys can kind of read a recipe, I equate it to sort of like, anybody watch the Food Network?
Yeah,
all the time. Yeah. Chopped? You guys watch Chopped? Okay. So, oh my God, I love it. Yeah, Chopped and Beating Bobby Flay. Yeah, love it. Cutthroat Kitchen. Yeah. So I equate it to being one of the cooks on those shows, and then us watching the show and doing a hack job in the kitchen. If you equate this to our coding experience, we're the hack job in the kitchen. So we're going to take a recipe, we're going to read it initially, and then we're going to discover little ways that we can manipulate it slightly without really understanding what's going on to get what we want out of it. And you'd be surprised if you guys feel comfortable enough going online and just grabbing code and seeing what it does and applying it to your scenes. You don't have to be a coder to get a pretty decent way. So what we're doing in here is we're basically just applying recipes. I'm trying to point out moments where we might go in and change something, but the two big things that you guys really just need to be aware of, most of the time the code things that we would change are already public variables that we have access to in the inspector, so we don't actually need to go into the code to do much. But the big thing to keep in mind is if you are going to snag code from the internet and try to implement it in your scenes, which we'll get to our VR test projects today, you might do, and I'll open it up as an extra credit opportunity. Big things just come down to naming conventions. Those of you in the dev class are learning that probably very quickly. If you see naming conventions in the code, you're going to want to stick with those naming conventions, and caps and spaces all matter. So that would be the big thing to keep in mind for the non-coders if you're going to tinker with stuff. But otherwise, stuff's online for a reason. Hijack it and see what you can do with it. Right? Okay, so let's all right, let's jump into the rollerball with a twist. Do some pretty stuff. All right. Okay, so let's open this up real quick. All right, so for those of you starting fresh, and actually that's what we'll do. We will start with a nice, prettier, fresher project. So I'm going to start new. We're going to go new project. Okay. We'll name it something that makes sense. We'll say rollerball. And then for mine, since I already have a project structure on here, I'm going to name it something different. So we'll call it prettier. Okay, and I'm going to toss it to my desktop. We're going to start as our 3D package. Okay, so for some of this, we kind of glossed over with the initial Unity project, but we can actually we can bring assets in that come with Unity or that you've downloaded previously. And if you were going to do that, you could do it right in the start menu as this add asset package. We don't have anything that we're going to bring in specifically, so we're going to leave this alone. Okay. All right, once this is all set, I'm going to go ahead and hit create project. It's going to ask me if I want to save this. I'm going to say no. Now, one thing to keep in mind, every time you open a new project, or even sometimes if you open, well, no, if you open a new project specifically, Unity will kind of close down and then start back up. So just be aware of that. That's nothing that you're doing that's weird if it happens. Okay. All right, so what we're going to do, similar to Rollerball, but with some added functionality, we're going to have our main character, which is our sphere, okay, rolling around this terrain, right? Something a little cooler than a box. And it's going to be searching for energy capsules, okay? It needs to pick up these energy capsules, and it needs to take it back to its home base or its ship in the center of our terrain that we're going to create. To make it a little bit more interesting, we're going to have enemies or protectors of this planet, if you will, on the terrain, and it's going to be chasing our character. So as our character's rolling around and picking up objects, it's being chased. If it gets hit by one of these defenders, it's going to lose all of its energy capsules, and if it doesn't have enough left on the map to get back to the ship, then it's stuck on the planet, basically. Okay? So the goal is this little thing's going to be rolling around trying to pick up these energy capsules so that it can recharge its ship and take off. Make sense so far? All right. So, in terms of our file management, on our assets, we're going to create a folder system. Okay. First thing, before we save anything, we're going to create our scenes folder. Now remember from last week, our project structure is really, really important, and we need to make sure that we're keeping that organized, right? Most of this we're going to do right in our Unity file. Now, the difference between this project from your Rollerball is that we have assets now that we're bringing in from something like 3ds Max or from Maya. So we're going to have models, we're going to have texture maps that we're going to bring in. Okay. Now, when we bring these into our project structure initially, we can drag and drop right to our window, you know, our Windows Explorer, and we'll see it populate in Unity. Keep in mind, once we start doing things to those assets in Unity, then we're going to want to start manipulating our structure, manipulating our organizational techniques within Unity itself. Does that make sense to everybody? Okay. So I'm going to right mouse click over assets. I'm going to choose create, and I'm going to create a new folder. I'm going to name this folder scenes. So just like before, this is where we're going to house the scenes that we create. And keeping in mind that as we create scenes, these would be kind of akin to basically levels within our game. Okay? All right. I'm going to repeat this process, and I'm going to call it a few other things. So I'm going to create another folder. I'm going to call this models. You could call it meshes too. It doesn't matter. I'm going to create another one, and I'm going to call it texture maps. I'm going to create one more, or a couple more, and call this scripts. So as we drag and drop stuff, we're going to be dragging and dropping and creating things in their appropriate folders. Okay. Now, could we create these folders in the Windows Explorer? Yes, we could. It wouldn't matter one way or the other. But for this, it's a good practice for you guys. So audio, because we're going to have some music in this. And then here's a caveat that I want you guys to note down on your notes. I have an additional folder in here called shaders, but really what it should be called is materials. The shaders is really a 3D thing, because shaders in 3ds Max and in Maya mean kind of the same thing as materials in Unity. But I do want to make sure that you guys understand that within a game engine, there's actually a distinction. Materials, and I'm just going to, I'll write this on the board, so if you guys want to take a note of it, you can. So materials in Unity, that is basically the container that houses information about the type of material that we're creating. In other words, if we want something to look matte or flat, like wall textures, carpet, tires, right? Things that are not shiny, right? We would have a material type specific to that. If we want something that's shiny, then we would choose a material that has properties that allow us to create shine and metallic properties and reflection and high gloss, high shine, right? So this is what the texture, so texture properties basically. So we want something to be matte, right? We want something to be metallic. We want something to be shiny, transparent, like glass. Okay. We'll have particular attributes that we can choose from depending upon the material that we choose. Does that make sense so far? Okay. Now, in 3D, this is where it gets a little confusing and why I kind of oops in the notes a little bit. In Max and Maya, this is called shaders, which is why I named it that way in your notes initially. So this is going to be Unity. game engine stuff. Okay, this is maximized. Now, shaders. Shaders. All right. So shaders in a game engine. This is actually script work. It's scripting your texture, right? And you'll see if we get as far today as our VR samples, there's actually a folder for shaders where you're bringing in scripted textures. So this is so has anybody worked with RenderMan by any chance? No? Okay. RenderMan I would say would be a good example. RenderMan RID files, grid files, are scripted textures. So that would be an example of that if you guys have played with it. But we are not going to write scripted textures in here. We're going to be creating materials and bringing texture maps in. Yep.
So are they scripted because they have a behavior? Like graphs that waves or something like that?
They can. Some can. Yeah. We'll talk a little bit about it too in those example files, and you'll see some of it, but yeah, some of them can. Real quick too, before I divert too far. So the textures then, texture maps, I should say. These are the files that we're bringing in. And these plug into these to give us look and feel. So color would be an example. And we'll talk a little bit more about this as we get going. So just to make sure that there isn't confusion as we move forward, if you guys want to name that folder materials rather than shaders, I'd probably recommend it just for consistency's sake. But if you hear me refer to shaders in here as a kind of a trip up because I'm used to working with it in the 3D programs, I'm 99.9% of the time I'm referring to the material. Sound good? Yeah, okay, good. Okay. Okay, real quick too, we're gonna create some subfolders. So in our models folder, I'm gonna create a subfolder called environment. And I'm gonna create another subfolder called characters. Okay, and using the external assets folder. Now, do you guys have all of you pulled this off of Basecamp yet? If you haven't, I want to give you a second to do it because we're going to be using models and textures that I've posted on Basecamp, and it's specific to this project. So do we need a minute to download that? Yeah, okay. So if you go on to your Basecamp, I'll show you where it's at. So funny. Okay, great. I'm not a robot. Goodness. All right, there we go. Great. All right, so in your docs and files, project files for assignments, that's generally where I'm going to put zip files where that'll contain assets that you'll need for projects that we're going to be going through or projects that you're going to be working through for your homework. So what you guys are going to want specifically is this is external assets for Rollerball with a Twist. Go ahead and download that. and unzip it if you need to. Most of you should be doing that. And when you open it, you're going to see a file system that looks like this. How are we doing? We need another minute. Okay.
Yeah.
Okay. Once it's open, what I'm going to do is I'm going to open up my project structure for the project that we're working on. And I'm going to go into my assets folder. And I see all the subfolders that I've created. And I want to start bringing over some of the content that we're going to be utilizing for our project. So if I go into my models folder specifically, I've got my two subfolders there. Okay. I'm going to start bringing over, I'm going to look first at my environment folder. I'm going to go ahead and open that up. Okay. And what I'm going to do is in my external assets, I'm going to go to the corresponding folder. So models, environments, and I'm going to see a bunch of what should be FBX files. Hopefully Unity recognizes that. All right. And what I'm going to do is I'm going to select all of these files and I'm going to copy them over to my project structure. As soon as I do that, you're going to, and you click back over to Unity, in the environments folder, we should now see all of our models being pulled in. Yeah, it's pretty cool, right? Now, one of the things we could have done, rather than dragging and dropping into the folder, is we could have also pulled these files from the external directly into Unity. That would have been another way we could have accomplished that same goal. Okay. All right, so let's do a little bit of cleanup. If we have one of these selected, I'll just click on my pile down here. Okay, this is one of the first assets that we're going to toy with. What we're going to see, and let's maximize this a little bit more. What we're going to see over in our inspector are some properties that are common to meshes that we're pulling in. Okay. Now, last week when we talked about our carrier scene, we brought a cup in, and one of the things that we toyed with was the scale factor, right? Now remember, if you change anything within the sort of global attributes, in other words, you're changing it down here when it's selected in your project structure rather than selecting it in your scene. If we dragged and dropped it over here, it's going to be a global change. So if I change my scale factor to say 10, every pile that I bring into my scene is going to house that same scale factor of 10, right? Okay. So let's take a look at a couple of these options. So down under our normals and tangents specifically, and we're going to also look at our materials here. So our normals drop down defines how our normals should be calculated. Okay. Does anybody, or can anybody tell me what a normal is? Does anybody know? Does anyone want to give a guess? Yeah, and then you go a little
my
telltale.
understanding is that normals like show how light hits an object or shins an object,
Good.
and then so that something that's two-dimensional goes three-dimensional.
Good. That's a wonderful explanation. Yeah, that's right on. Yeah. So it provides us the illusion of depth, which is cool, right? So where this is going to pertain to us on the CG side is we're going to create models that have a lot of geometry in them. Generally, you're not going to bring models with heavy geometry into a gaming environment because they just slow things down too far, right? So remember last week when we were talking about the lines, the like paper mache of a cube, all right? Is everybody good with this? Can I erase it? Yeah. Okay. If you document your project structure, yeah, it should do it. Oh, so yeah, yeah. Minimize unique. So where's your project structure? Oh, there. And you'll see it up there. So you click on do. Yeah, it's crazy. It's crazy easy. How it almost seems like it should be more complicated. Yeah. Yeah, 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 cool. Yeah. It's up to you guys in terms of how you make this thing work. Okay, so back to the normals here. All right, so remember last week we talked about our cube and we talked about the different components of a piece of geometry, right? So we've got our edges, we've got these points, which we'll worry about later, called vertices, and then we've got the faces, right? Okay, well, as we create more complex pieces of geometry, they're gonna have a lot of edges. Maybe we even have some over here, because everywhere we have an edge means that we can move it and deform its shape, right? So the smoother something looks, the more complex it is, we're going to have a lot of these. Okay. So this would be a high poly model. Now, for beam engines, what you have to do is we have to basically take that high poly information and we have to bake that information into a texture map so that when we pull the low poly version of this, that was a mixture of both. So let's say we then have a version of our cube, okay? Beautiful drawing skills. We have a version of our cube that's low poly, meaning we've taken away a lot of those edges. What we would do is we would bake this information out into a texture. We'd apply the texture to the low poly to make it look like this high poly one. It loads a lot faster, it plays a lot faster in the game engine. Does that make sense? So a normal map is really a pivotal component in that, because just like Aurora stated, it's taking a lot of the lighting information, it's creating the illusion of depth for us. And it really is an illusion here. And it's making something look more detailed than it actually is. So for example, what if we wanted to have a brick wall in our scene? Well, one thing we could do is we could go in and we could create the individual bricks. And we could line them up on a plane, go in and have individual textures for each thing. And what would happen is the light then would catch all of the shadowy areas where the bricks are close to each other. Make sense so far? The only problem with that is it's really dense. So for game engine, probably you're not going to want to do that. So what would be an alternative to that would be to take the lighting information that we would generate from lots of different bricks and put it on a plane to make it look like we have a lot of bricks there, but really it's just sitting on a plane. And it's going to make it look like we have depth there because of that lighting information. So what creates depth for us in terms of light? What do you guys think? Shadows and on the other side of it? Highlights. That's what we're getting, shadows and highlights. And it creates this illusion. Now here's the caveat in normals. If we were to turn, for example, our plane on its side, we're not going to see that depth represented in the silhouette. Does that make sense? So we're not going to see bumps on a plane. We're going to see just a plane. So it really is relevant to kind of how we're working within our scenes. Now, that all said, one of the things that will come up later when we're working in our sort of VR test projects, something that we're going to have to consider when we get to the texturing component is, will we have normal maps in our scene? Yes. But for VR specifically, normal maps don't work as well as they do in games when we're playing on a monitor. We'll use them, but we'll have one additional map that we're going to need to use in conjunction with our normal maps to make it look real in our VR environments. Okay. That map is called a height map. You might also hear it referred to as a parallax map. Okay. We'll talk about that stuff. But for now, for the scene that we're going to be working with this rollerball, you're going to notice that for a lot of the geometry, we're pulling in normal maps. And it's because we basically have these giant blobs that aren't going to really look like anything until we put our textures on there. And the normal map is going to make it look like it has depth. So far, so good?
Can you say a little bit more about what baking means?
Okay, so basically, yeah, that's a good question. So baking, I'm going to describe this like, so basically, let's say we have this high poly model in Max. What it's going to do is it's going to take this information back, and it's going to take this information for the high poly, and it's going to create the texture for us. That process of taking this information and creating a texture out of it is called baking.
Okay.
Does that make sense to everybody? Yeah. And you'll see it in the interface, it will actually be called baking. It's sort of, yeah, it's sort of a funky way, but that's what it's referring to. We're just taking information and we are putting it into a texture. Yeah. Good question. Okay. So that's what normals are. So when you hear me refer to that throughout this project, that's what I'm referring to. Simply a texture map that we're applying to geometry to make it look like it has some depth attached to it. Okay. Tangents, we'll leave that alone for the moment. Imported materials down here at the bottom. These are going to be materials applied to the model that are brought in. So if, let's say, for example, I created this pile in Max and I had some kind of texture applied to it in 3ds Max. This materials or import materials is going to make an attempt at bringing that in. I'm not going to do that. We're going to apply it right in Unity. So we can uncheck that imported materials. With it checked, you're going to know that a material was imported. And if I pull that, let's see. Yeah, we'll go ahead and leave that. Okay. So what we're going to do, we're going to get rid of that, and we're going to do that with the intention of creating our materials right in Unity. The other thing you're going to notice is that as a material or as materials are imported from your FBX files out of Max, when we import these objects, see how it created a materials folder, a subfolder within my environments? I'm going to go ahead and hit apply. So anytime we make a change over here that's global, it's going to ask if you want to apply it. We're going to go ahead and hit yes. We now no longer need this materials folder. So I'm going to right mouse click over it and I'm going to hit delete. It's going to ask me, are you sure? I'm going to say yes. We're going to apply our own stuff. Okay. Now, as soon as we do that, and as soon as we have unchecked our import materials, if we scroll down, if we click on our pile and we scroll down, we're now going to see that Unity has applied a default material for us. Okay, so that's what we want.
And should we do that for each of them individually?
Yeah, we'll need to. Yeah, we'll need to. Okay.
Oh, yeah, because now I need to put that on the list.
Yep, and that's all because it doesn't know that we don't want that imported material. Okay, so we're going to notice if we click on this stuff, our assets no longer have materials associated with them and they've turned pink. It's because that link has been disconnected when we deleted our materials folder. It doesn't know what to apply to it anymore. So what I'm going to do is I'm going to shift select all of my, actually, you know what, the one that we are going to do, we'll come back to that. Okay, so I'm going to shift select all of my materials or all of my objects right now. And I'm going to uncheck my import materials. It's going to ask if I want to apply. I'm going to say yeah. Now all of these should have a default. So I don't need to go in and click them individually. Makes it a little easier, right? Okay. Okay. So let's do some cleanup on this. If we click on the arrows of our icons, you're going to notice that it's got a drop-down option available to us. And what that is simply the component that makes up that object. So it's going to be our mesh, basically, that we brought in. For most of these are going to be fine. But let's say we click on our rock large option. You're going to see that it's got a little avatar associated with it. What this means is that animation components have been added to this asset. All of our environmental assets are going to be static, meaning they're not going to move, they're not going to be animated in any way. So we actually don't need any animated properties associated with our environment. So if we click on the root of this and we go over to our inspector and we look down where it says our model attributes, we're going to change this, or our model tab, we're going to change this to animations. And we're going to see that import animation is checked on. Okay. The other thing that we're going to look at is in our model attributes down here at the bottom. Where are you? This area, this animator section, you guys see that? It's going to be grayed out. So we're going to want to clean some of this up. So I'm going to shift select all of my rocks. Because I want to make sure that I don't have any avatars attached to it. I don't want to have anything that's animatable. In my inspector tab, under rig attributes, under animation type, right now we're going to find that there's a dash there, and what this means is that some of these meshes have different animation types than others. We're going to change this to none. None of these rocks need a rig, because in order for something to animate, you need a rig. Nothing's going to animate. Okay. So now it's going to ask me, do I want to apply? I'm going to say yes. Okay. Now if we click on this rock underscore large, we no longer have an avatar or an animation associated with it. Okay. That's going to null out any animated properties. It's not even going to consider it. Okay. So far, so good? Yeah. Okay. Yeah, I might leave that up for the moment. Okay. All right. Next thing we're going to do, let's bring in the textures that we're going to associate with our models, because right now we just have a bunch of grayscale stuff. Okay. So on our texture maps folder, I'm going to click on it and I'm going to create some subfolders for our texture maps. Just like I did with the models, I'm going to create one called environment. Okay. And I'm going to create another one for character. All right. So just like we did before, I'm going to navigate to my project structure. I'm going to look into my texture maps folder. Let's start with environment. So I'm going to go ahead and click on my environment. Oops, I'm going to make sure I'm looking at the right thing here. There we go. All right. Now I'm going to drag and drop texture maps from my external folder to my project structure. So look at my list. All right. So you're going to see I got a bunch of stuff in here. I'm going to go ahead and grab this and just copy it over. Okay, now when I go back to Unity, I should now see in my texture maps environment folder, I should now see that information being populated. So we'll give it a second to read in. Okay, so go to my environments. Boom, there are all my texture maps. And we'll talk a little bit, just kind of gloss over an overview in terms of what these are, but you'll see all these purple ones. These are our normal maps. These are the ones that are going to be creating our depth information for us. Okay. Okay, so what we need to do is we need to create prefabs for our rocks. So from Rollerball last week, who can tell me what a prefab is? Anybody remember? Yeah. Mm-hmm. All right. What's that?
Like a simple piece illustrator, and you create a symbol.
Yeah. Or instant, I like to refer to as like an instance object. So what we're basically creating is we're changing properties of something so that we only have to change the properties of it once, and every duplicate we create from there on out will hold those properties. Anytime that we drag and drop something from our hierarchy into our project structure, it's going to create a prefab for us. And once we start making changes to those prefabs, when we apply it over in our inspector, it should update all of the prospective duplicates, right? So it's a workflow thing. It just makes our life a little easier so that we don't have to keep doing the same things over and over and over again, which is nice. All right, so let's start by creating some prefabs. So I'm going to go back to my models here. I'm going to go back to my environment. Let's drag our first rock into our scene. I'm going to drag and drop it. And if you want, we can reset it back to our origin. So how do we reset something back to the origin? Give me 2 ways that I can do this. Yeah, Aurora, go ahead.
On transform and right-hand corner there's a gear.
Yeah. Good. That's the quickest and easiest way. Excellent. I like it. All right. What would be the other way? A little slower way, but I can do it. Yeah. Oh, I see. Okay. Yeah. So we could, so you're talking kind of manually. Yeah, we could go in and we could kind of, we could adjust it using our handles. It gets a little tricky for us to get it right on to do that, but we could. We'd fuss with it probably a bit. What's another way? Probably what are we resetting over here? Our position fields, yeah. So we can go in and we can type values in, right? So we got legitimately 3 ways of doing it, all with pros and cons. Okay. The other thing I can't remember if I mentioned, but anytime you hover your mouse over one of these attribute boxes, see how my cursor changes? I get 2 extra little arrows on either side of my cursor arrow. You guys see that? If I click and drag from left to right while that is active, that allows me to interactively change values within this box. Sometimes that can be really helpful. So I'm just hovering my mouse over one of, let's say, in position. Why don't you guys try this? Hover your mouse over the letter X next to position. See how I now have 2 extra arrows? Now click on your left mouse and drag from left to right. So sometimes that's a little easier to deal with when you're working with your values in your attribute boxes rather than going in and typing numbers. You kind of want to interactively see what the change is going to do. That's one way to do it. Okay. But otherwise, if we're just resetting to the origin, using that little gear up in the upper right-hand corner is a really straightforward way to go. All right. Okay, so who can tell me what the hotkey is to move? You remember? You refer to your notes too if you guys need to. It's your cheat sheet. Yeah, all right, W, excellent. So W allows us to move. So what's the sort of rule of thumb I've told you guys with regard to moving or using your move tool? Yeah, grab it 1 handle at a time. Why would I not necessarily want to grab in the middle?
Because then we'll move on all of the actions.
Yeah, and in Unity in particular, I find this really hard to keep track. You're going to find it's a little easier to deal with when we're in Max or Maya. We can grab in the middle and kind of fuss with it a little bit easier. It's still not great. But in Unity in particular, I really don't like it because you have absolutely no idea in space kind of where you're actually shifting to. So grabbing on one of the handles and moving it very purposefully in that direction is a good practice for this. Okay, what if I want to go into my rotate? What's rotate? E, good. Same principle here. Make sure you're grabbing in the direction that we want to rotate in rather than grabbing in the middle of those spheres. And you're going to see if you grab in the middle, it gets crazy really fast. All right, so I'm not going to want to do that. All right, how about scale? What's scale? Someone other than Aurora. What's that? R, good. All right. So what about R? Can I grab in the middle? Yeah, and probably most of the time you will for this. It's going to provide us nice uniform scales. Good. Okay. Okay. So first thing, let's talk a little bit about components and adding components to our piece of geometry. So what we need to do is we need to add a component, or an attribute, as sometimes you'll hear me refer it to as that. An attribute so that this rock basically will be collidable. If our character rolls into it, it's not going to roll through it. Okay? So basically what we're going to do is put a barrier around it to dictate how close the character can get. Now, in our previous examples, you know, we use very simple pieces of geometry, like a sphere collider or a box collider. So let's try that and let's see kind of what we get. So to add a component, we're going to click on our piece of geometry, and over in our inspector tab, I'm going to click on the button that says add component. We're going to use this a lot to add things to our assets. Okay. So we're basically piggybacking assets onto this thing to make it either functional or to make it look nice or to do something, right? So in this instance, I'm going to go to add component. I'm going to choose physics, and I'm going to scroll to 3 options down where it says box collider. So what would happen with this is that our character would run up to the rock and it would get stopped by that bounding box. Wherever we see that box, that's where the character is going to basically like hit a wall. Okay. This is a little bit problematic for this type of geometry. And why would you guys think that this would be potentially problematic? Right, it would feel weird. Yeah, it would feel really weird, especially as a player. You guys, when we play games or we're in VR, we like to explore. So generally speaking, when we have pieces of geometry like this, we like to get kind of close to it and see what's going on. It feels weird when we can, especially if we run up to like this invisible wall before we ever get to the object. And that's essentially what this is creating for us, is this very strange invisible wall. It's not going to feel natural. All right. So we would actually rather go with something else. We want something that's going to conform a little bit better. So what I'm going to do, if I don't want a component onto something, removing a component from a piece of geometry is actually pretty straightforward. If we go over to our inspector, we can click on the gear in the upper right-hand corner of that component that we created, and we can choose to remove it. So that's what I'm going to do. I'm going to remove it because it's a little strange for this particular piece of geometry. Okay, so let's try something else. Let's add another component. We're going to go into physics again. And let's choose mesh collider. All right, so we've got a mesh collider on here. And what this is doing is it's created a collider that matches the shape of our rock perfectly. Like it's right down to the T, which is why we can't see it specifically. Okay. This has some problems with it though. Okay. And it's not something that we're going to want to typically do. And the reason why we don't want to do this is because we're actually doubling up on our mesh attribute. On our mesh attributes, meaning we're doubling up on vertex count, edge count, face count. And it's a problem for memory. We don't typically want to double up on that geometry information if we can avoid it. We don't want to do that. Okay. All right, so in our inspector tab, what we're going to do, this is an easy fix. On our mesh collider drop down, under the mesh attribute, we're going to assign another mesh to this. So rather than assigning its own mesh on top of it, we're going to assign something else that we've created. And this is something that we would do in a CG package, is we will have created a dumbed down version of this rock, something that's a little bit lower poly. So, you know that principle that I was talking about up there? Something that's a little bit less. Okay. So to assign a new rock to this, I'm going to click on this little circle. You guys see this? Next to the mesh text box. If I click on that, it's going to pull up a dialog box for me. And I like to look at this in terms of the list. Okay. And what I'm going to choose instead is this rock large underscore, and what the naming convention represents, COL stands for collider. Now, here's something that you're going to want to take note of, and we can see it now in our workspace. You guys see it pop up? It's not as awkward as the box collider, and it does conform to our mesh actually fairly well. Oops. Okay. But if we click on our rock, and if we actually will click on it in our project structure, our large rock, and we click on the model, and we should start to see, why am I not seeing information here? Okay, that's okay. We can even just evaluate the collider. So I'll pull this collider back up. One of the things we're going to note down here at the bottom is we can look at it here. All right, so here's my original rock. What I want you to look at is down here at the bottom, it's giving us information about that piece of geometry. Our original rock has basically 2,300 vertices attached to it. Our collider has 184. That's significantly less, and it's going to eat up a far less memory than if we attached the one that has 2,300 verts associated with it. So I'm going to pull this up again so you guys can look at it. Okay, so I'm clicking on my rock here. I've attached this mesh collider, and where I'm looking at this information under the mesh option, I'm clicking on the little circle to associate a collider with it. And within that window, it's giving me information about these objects. So I want to make sure that rock large A underscore collider is what's selected as the collider option. Does that make sense to everybody? Are there any questions? And are there any questions as to why we're doing this? No? Good. Okay. Cool. And we can see it, so it's a little easier to deal with. It's going to be a little less obstructive than the cube is going to be. All right, so the next thing we need to do is we need to make this a prefab. So I'm going to create a prefabs folder in my assets. So I'm going to click on assets folder in my project structure. I'm going to right mouse click, go to create, choose folder. And I'm going to name this prefabs. Okay. Next thing I'm going to do is open up my prefabs folder. And in my hierarchy, I'm going to drag my rock large into my prefabs folder. Okay. Now the thing to keep in mind, anytime I drag something from my hierarchy down to my project structure, I have created a prefab for it. It doesn't really matter what my folder is called, but just to keep things organized, name it appropriately. Okay, so now when we make changes to this rock and we hit apply under our prefab options, okay, and you can see if I click on my rock up here in my inspector, see how I now have a prefab line associated with it? anytime I make changes and I hit apply to this now, it's going to apply to all of my rocks that I have the prefab created for. Okay, so I've created an instance basically of this thing. Okay. Some of this I think I might. So I'll tell you what that is. Okay, so moral of the story, prefabs are going to allow you guys to make changes to things very, very quickly. Use them when you can. They're a powerful tool. If you ever need to change the main asset itself, we can double click on the asset in the project browser and it'll pop up the native file. We're not going to do that, so I don't want you guys doing that right now. But basically what that means is in my project structure, if I go to my environment, let's say I want to make changes to this thing. I want to change the shape of it. If I double click on this rock underscore large, what it'll do is it's going to open it up in the software that it was generated in. So in this instance, it would open up Max or Maya. I could go in, make a change, save it, and there is legacy saving capability with this, meaning any changes I would make and then save, we should see the update happen within Unity, which is also really nice. Okay, but we'll go ahead and leave that for now. Okay, so what I would like for you guys to do right now is let's go in and let's create prefabs for each one of our rocks. So this will be a good practice for you guys. We're going to create colliders for each rock, and then we're going to create a prefab out of it. Does that make sense? So we've done the first one. Let's start with our pile. So why don't you guys all do this with me? I'm going to drag pile into my scene just so I can see it. You want to reset it. And actually what I've done, or just to get it started, is I'll go in and just kind of line everything up off of my origin. And then I'll shift it over. So we'll start there. We got our large rock. Let's do our medium rock. I'm going to put this back at the origin and just shift it over. I'm just going to make a line of my objects so I can go through it kind of like factory style and create my prefabs. So I got medium A, medium B, medium C, oops, small a, small b, okay, so we'll just go on down the chain here. I grab my pile. Who can tell me what the hotkey is to focus in your camera on a particular object? Who remembers? F. Good. F for focus. Okay, so here's my pile. I'm going to add component. I'm going to go to physics, mesh collider. And now I need to change out which collider is associated with this. So I'm going to click on my little circle. I'm going to find pile A underscore collider. And if at any point you have a hard time finding something, you guys can always type in, and let's see, where is it? I'm finding it, pile A. Let's make sure I didn't bring my collider in. No, I didn't. Okay, okay. Oh, it's mound. Okay. So it's called mound A underscore collider. That's fine. Use that. Let's go to the next one. I'm just going to add my colliders first, and then I'll make my prefabs. So for my rock M underscore A, let's create physics, mesh collider, rock M, A collider. And you'll know right away if the right collider gets attached to it. It should adhere reasonably to the shape of the object that we're applying it to. So MB collider. C collider. Small collider. That's not that one. That one. There we go. And then B collider. Okay. Once I have those colliders created, I'm going to go back to my prefabs folder. And I'm going to drag all of these pieces of geometry that I just put the colliders on from my hierarchy into my prefabs folder. File, rock, okay. Okay, so now I've got prefabs for each of these that all have colliders on them. Right? So do you guys need a minute to finish that? To do that? Yeah? Okay. What's that? All right, once you have those created, actually we could probably even just leave them, so we'll leave them in our scene. Okay. All right, need another minute, or we good to go? Cooking along. What's that? Good to go? Okay. Okay, so at this point, we now have a little bit of functionality to this. In other words, our character is not going to run through them, so that's good. And we've been performance conscious, so we're not duplicating the same number of vertices on our mesh. Next thing we want to do is we actually want to make these look like something other than big old gray blobs. Let's give them some prettiness, since that's our whole goal, right? We can start with our tall rock here. So the first thing that we need to do is that we need to create a material for this. Now, I may have mentioned it briefly once before, but materials are kind of like empty containers. And what we're going to do with them, and this empty container maybe holds a set of very specific properties based off of the type of look and feel that we want to create, right? Matte surface, shiny surface, all that stuff we were talking about earlier. And what we want to do is we want to dump stuff into this container to give it that particular look and feel. So things that we can dump into this container: color, our normal maps. For example, those would be two big ones right there. And as this gets dumped in here, the material then gets applied to our piece of geometry. So this material is always sort of the end thing. It's the final thing that gets placed on the geometry, and it's giving us the information that's contained within it. Does that make sense so far? And the reason I'm bringing this up now is because the same principle applies when we get into the CG packages. Same idea. It's going to translate. So what we need to do is we need to create a material to apply to our geometry. We can't just throw a texture map onto it, for example, right? Everything needs to funnel through the material itself. So let's do that. In our materials folder, I'm going to right mouse click. I'm going to go to the create menu, and I'm going to choose down here about a third of the way down the list. There's an option for material. I'm going to create it. And this first material, I'm going to associate with the object that I'm going to apply it to. So I'm going to keep naming conventions consistent. I'm going to call this rock underscore large underscore A material, or MAT for material. So that I know that I'm creating this particular material and it's going to be associated with a very specific piece of geometry. We want to keep naming conventions consistent. Okay. And the reason for that as well is that when we actually get to a point where we're creating our own materials, the materials aren't going to be something that we can just plop on any piece of geometry if we have specific maps associated with it. And with this, we have specific maps that are adhering to the shape of this piece of geometry. So if I put it on the pile, for example, it's going to look really weird because I'm going to see definition that's specific to this. So naming conventions will maintain important or be important for us. We'll want to keep that. Okay. Okay. So first thing, over at our inspector, we need to define the type of shader that we are going to use. And up at the top, this is where we do this within Unity. We've got a drop-down menu where it says shader. We've got standard. We have another option under here called standard on, with a specular setup. We're going to go ahead and just leave it at the standard option. This shader uses what's called physically based rendering, which is very specific to our game engine. So we're going to go ahead and stay with that. And we'll talk a little bit about more of the differences of some of this stuff once we get to the texturing component of things. But for now, we'll keep it simple. So under our main maps, this is where we're going to start associating those texture maps that we brought in earlier. So the albedo channel, which I think is such a funny naming convention for this, is the primary color that we're going to attach to this. So for example, if I wanted to put a texture on a wood floor, rather than going out and, you know, making the individual wood pieces, what would be easier would be to put a plane down and go online, find a flat image of a wood floor, and place that on the plane. That's what we're doing here, basically. Okay, that's the color information. It's purely color information at this point. Okay, so it would be something that we could go in and we could create in Photoshop, for example, or we could go online and we could find flat images to apply. So the benefit to doing something like this is that it gives us a lot of detail very, very quickly without us having to do a lot of messing with it. It does use raster-based images. So when I say that, do you guys know what I'm referring to? Some of you do, some of you don't. Okay. So a raster image, and for those of you who do know what raster images are, what types of programs would you use a raster image in? Any idea? Yeah, Photoshop is a big one. Can I erase this, or do you guys need it? Good? Okay. Yeah, Photoshop is a good example. Okay. Yeah. Yeah. What's that? You said that? Yeah. Yeah. Good. What's that? Yeah, I'm not as familiar with Mari, so I guess. I'll take your word for it. But yes, I've heard good things about Mari, so I haven't played with it myself. All right, so we have basically two types of image files that you guys could potentially work with. Raster And then you might also hear about vector. Does anybody know what vector image files are? Just so that we have a difference here. Yeah.
Oh, they're, instead of being static images, they're generated at runtime, so they don't use memory in the same way.
Okay, good. So they're kind of mathematically generated, really. Yeah. So what this means is that they're scalable. Excuse my spelling. And you don't lose quality. So I can scale this image up and down all day long. And it's going to remain as crisp and clear as from the moment I generated it. So does anybody have some examples of vector-based programs? Yeah, Illustrator, Flash. Yeah, those would be good ones. All right. So for our purposes, we won't be in this world, but you may hear it. So I just want to make sure that you guys understand that there is a difference. Raster-based images are what we're going to work with in our 3D applications and our game engines. So what this means is that scale matters. So if I go and I pluck an image off the internet, go into Google, type in whatever, it'll find some image that interests me. Most of those images have a resolution attached to it. You know, maybe it's 1024 by 1024, maybe it's, 540 by whatever, right? What this is referring to, if I look at my image here, are how many pixels it takes to generate that image going from left to right and top to bottom. Okay. The more pixels that we have, the higher the resolution and the crisper our image looks. So far, so good? Okay. If we were to take this image and we were to scale it up, what happens to our pixels? Any ideas? They get bigger. No, it doesn't add pixels. These pixels just get a lot bigger. When that happens, you get blurry images. So you guys have probably noticed if you ever gone out and take a photo with your camera and you tried to scale it up and it got blurry on you. That's why. It's because there's a set number of pixels, meaning there's a set piece of information in here that makes that image crisp. And as we blow it up, we're not adding information, we're simply taking the information that's there and blowing that up too. And so we get really blurry images that look kind of off, right? Okay, so why this matters to us. If I go online, let's go back to my brick wall or my wood floor example. Let's say I want to put a nice hardwood floor in my CG scene. So I go online and I find a nice flat hardwood floor image and I slap it on my plane. The resolution of that image is going to matter because as my plane gets bigger, what do you think is going to happen to my image? If we make our image bigger to fit that, it's going to get blurry and our viewer or our users are going to see a blurry wood floor in our scene. Now, there are ways in CG that we can dodge around this a little bit, and it has to do with tiling textures, but we'll get to that. And all that means we can take an image and repeat it, so we don't have to blow it up. But in doing that, we have to make sure that if we repeat it, we can't see the seam lines. We can't see where the image starts and ends. So we'll talk more about that, but I at least want to get so that you have some basic concept around images that we're pulling in, and the sizes of those images do matter. Does that make sense to everybody so far? Yeah. So we're going to be in this world. Sadly, we're not going to be. Yeah, I know, right? And where it becomes also important in VR and in our game stuff is that as our images get bigger, it's more taxing on the system. So we have to find ways of being conscious about that so that we're not taxing our VR or our game environment. All right. Okay, so albedo, this is our color. And we're going to assign something to it. Our metallic basically is an option that provides metallic properties to our piece of geometry. And when we're determining what type of shader is going to be, or material type is going to be most appropriate for our model, we need to think about properties that we're trying to convey. So color itself, that's pretty straightforward and going to be consistent really for any material that we create. Highlights, is it metal or is it dull? Does it involve transparency, and so on. One thing you're going to notice, if I were to switch this to a spec, this is kind of more of a traditional CG setup, and it's going to give us a specular option. Specularity, if you hear that word, all it is a fancy word for highlight. That's all it means. I remember when I first started working in CG, that word got tossed around a lot and no one actually explained to me what it was. I was like, it took me forever. I was like, what is this thing that they keep talking about? I have no idea. All it is highlight. That's all it's referring to. We can manipulate the highlight on a piece of geometry. Done. All right, so if you hear that, that's what I'm referring to. Okay. All right. So for our rock, if we kind of keep that in mind, do we need our rock to be metallic? Probably not. We might have other things in our scene that we want to have metal attached to. So I'm going to change the shader for the sake of our rock, since we want them to be a little bit more matte. I'm going to change it to the standard spec setup. That way we're not reading in metallic properties. So let's start applying some textures to this. So to apply something to one of these channels, it's pretty straightforward. Anytime you guys see one of these little circles, that means that we can attach something to that channel. So if I click next to the albedo and I click on the little circle, it's going to pull up my texture dialog box. And what it's going to do, anytime we pull up dialog boxes like this, it's going to scan through our project structure and see what might actually be applicable to what we would want to plug in here. So what I'm going to look for specifically is my large rock. Rock, large. Let's see, where are you? This is why naming conventions are so helpful. Ooh, come back. So rock, large, underscore A. And I'm going to look specifically for underscore ALB, and what that's referring to is albedo. Okay. And why don't we assign this material to our rock so we can actually see the changes that happen. So in our materials folder, go ahead and click on the material and drag it over the top of this first rock. And you can see in doing that, we now have colored. It's much prettier. Actually looks like something other than a giant gray blob. All right, so let's go back to our material. The next thing we're going to do is we're going to add some specular highlights to this. So I'm going to click on my spec channel. I'm going to look for rock large A underscore spec. Okay. Changes for that will be subtle. It just has to do with how the highlight's going to interact in our scene. And then the next thing I'd like to do is actually add a little bit more depth to this by applying our normal map. So if I click on normal map, I'm going to scroll to where it says rock large underscore A normal. Okay. Now we're going to notice that this is going to turn our geometry dark. It's not going to do what we really want it to do. It just means that Unity is not recognizing this as needing to be read in as a normal map, and we need Unity to do that.
So I'm going to go ahead and select it. The nice thing is it's going to try to help us out. So in our inspector, it says this texture is not marked as a normal map. If we click on the fix now, it'll adjust it for us. Okay. All right. So now we actually have something with a little bit of color to it. And we've got something with a little bit of depth and some specularity, and it looks a lot nicer. Than just that gray thing that we had. Next thing I want to do is I want to make sure that for every large rock that I bring in, it maintains those properties. Because if I bring in my large rock out of my prefabs folder, so everybody look up here real quick. If I grab my large rock and I bring it in, it now no longer has those properties. I need to make sure that any changes that I do to this thing, I am applying to all of the prefabs. So to do that, if I select it up in my inspector under the prefab section, I need to click apply. Now, when I bring in another large rock, it's going to have the material applied to it. That way I don't have to go through the same process every time of dragging and dropping a new material onto every single rock I bring into my scene. It's annoying and it takes time. Okay. So far, so good? All right, another thing that we might consider doing, and this I don't necessarily, I think I have buried in your notes somewhere, but if you want to just take a quick note, it'll just help expedite our process a little bit. If we go to our environment texture maps, one of the things that we can do for each of our normal maps specifically, so we don't have to keep clicking on fix now every time we want to use that thing, is we can go through this and we can actually tell Unity, hey, this is a normal map. We need to bring it in and have it read in as such. So what we can do is in this texture maps folder, if I click on each of these, so let's say I'll click on my pile underscore normal, over in my inspector under texture type, I can change this to normal map. And it will now recognize that texture as being a normal map. So anytime I apply it to something, I don't have to fix it. It's going to read it in appropriately. So what I'm going to do for each of my normal maps, it's going to say apply, yep. I'm going to go through each one of these purple, anything that has an underscore NRM attached to it, I'm going to go in and I'm going to change the texture type to normal map and hit apply. That way I don't have to fuss with it.
Oh, you search for NRM.
Yeah, we can grab all these too. That's fine. Sector type, normal map. Hit apply. Boom. Just take a second. Okay. So each of these bad boys now should be recognized as a normal map. So now we don't have to click the fix all. Okay. Next thing I'd like to do is I would like to apply my textures to each one of these rocks and make sure that the prefabs for each of these are updated. So when we start bringing these into our scene, we're good to go. We can add as many or as few as we want to do our set dressing. So what I want you guys to do is take a moment and I want you to go through each of these and I want you to practice what we just did. So I'll do it. So if you need to watch a couple more times, you keep your eyes up here for a second. So I'm going to click on my pile. I need to create a material for it. Or I need to create a container to house this information. I'm going to right mouse click under my materials folder, create folder, or excuse me, not folder, material. I need to create a material for it, not a folder. There we go. Where is it? Material. All right, I'm going to keep my naming conventions the same. So I'm going to say rock underscore, let's see, which one did I choose? Pile A, yeah. So this one's my pile. Underscore material. going to go in and I'm going to assign each of my materials. So for my albedo, I'm going to click on that button, choose Pile, Albedo. You can choose Normal Map. And I can choose my spec. Now I need to make sure, actually, I probably should have shifted my material over. And as soon as I do that, it's going to give me a spec option rather than a metallic option. And now I can assign my pile underscore spec. I'm going to take my material and I'm going to assign it to my pile. To make sure that the prefabs update, select my pile. Under prefab and inspector, I'm going to choose apply. All right, shift to the next one. So this is my, I'm just going to actually copy this so I don't have to type it. Let's create a new material for this one. Okay. Change it to my spec map option. Go under albedo. Find rock MA albedo. Bring in my spec map. Bring in my normal map. And I think so the normal map for each of the medium rocks is just rock underscore M normal. They're all using the same one basically. Okay, I'm going to assign this to my medium rock. Shift to the next one. Create a new material. Adjust for my spec. Add my albedo. So this is rock MB. Rock MB. Normal. Apply it. Now, one thing I forgot to do for these is I need to make sure that my prefabs are being updated. So I'm hitting apply on my prefabs. Don't forget to do that.
How is it that multiple items can have the same normals and look so different?
Well, it depends on the normal map. So there's a good chance for this one. I didn't generate the normal map for this. I'm thinking what it is it's more of like an overlay for like grainy detail rather than like really depth, like
You
big
mean
depth
that, like,
details.
yeah, like that. And then the one on the next to it doesn't have that.
Yeah, so let's grab,
The same normal map.
yeah, I know, it's a good question. So mat A, let's grab this. Choose none. So this color information is embedded in the albedo map. That's what's happening.
But
They're painted textures.
so the shape of it is in the albedo map?
Yes, which we'll get to.
Okay.
There's a lot of that information that oftentimes we will paint in. In Photoshop, you'll take the model basically and lay it flat like roadkill,
Yeah.
and you'll paint right over the top of it. So a lot of that, some of this depth information is just is directly painted right into the map, which is fine. It's another way to do it. Yep. So I'm gonna grab that, pull my normal map back. Yeah, and you can kind of see, so see what happens when I add this normal. It's kind of just adding generic dents and scrapes and grain. So it's not, it doesn't necessarily need to be specific. Not always. You can do overlays like this. Yeah. So let's grab the C here. C. Matte. quick. Okay. So this is good practice for you guys in creating materials. So what's this one? Do you overlay on this one? Let's see. Yeah. So on for the normal maps for those last two, the ones that I'm applying is this rock overlay normal. If you want to do that. Again, it's just kind of a broad, dents and bruises kind of thing. Dents and nicks and alright, let's grab this last one. It's a small E. Okay. All right, once you have all of your rocks with the textures, you can select them in your viewport and delete them. And if you just want to check to make sure that your prefabs got updated appropriately, you can drag them back in and just double check. Oops. You're not letting me drag you back in. Oh, oops. There you go. Yeah, so those all look good. Okay. And we won't need these in our scene yet because the next thing that we're going to do is we need to create the environment that these rocks are essentially going to live on. So once our prefabs are created, we can go in there and start adding things accordingly, but we don't need them just yet. So why don't you guys take a minute to finish up your materials, and then we'll take a break after that. And when you guys come back, we'll start talking about terrains. So give me the heads up when you guys are done adding materials. I want to make sure everybody is at least this far before we move to the next step. While folks are finishing up, are there any questions with the material stuff? No? Prettier than rollerball? Yeah. A specific name? Yeah, yeah, yeah. making stuff.
Oh, it's because you're talking about your so any of these CLOs. You just want a lot of that are not CLO. You see a lot of in here so because it's really water. Yeah, yeah. That's why I was You're good. Booby trapped with me.
So just real quick, guys, because I'm seeing a couple of you do it, and I wasn't probably explicitly clear on this. When you're bringing your models into your scene, you don't want to bring in the collider meshes. So anything that has an underscore COL attached to it, you're not going to drag and drop that into your scene. You're simply using that to attach to your collider component of the object it's associated with. So for my rock large, for example, I'm only using the underscore collider meshes to attach to this mesh collider. That's it. I'm not actually bringing those into my scene. Does that make sense, you guys? Yeah? Okay. Okay, good.
Have we created a scene already?
We haven't yet. Or did I? No, we haven't yet. We'll say once we have this, we'll go ahead, and once everybody's back, we'll go ahead and save it, and then we'll create our terrain. We will be, yeah. I'm just kind of waiting for people to get caught up a little bit. I think some people were left preemptively. But okay. What's that?
no.
This is good. You guys are finding things that need to go back in and adjust. All right, so for those of you who are caught up, let's go ahead and take a 20-minute break. Those of you who want to use the time to get caught up, you're more than welcome to. But it's 3:10 right now, so come back at 3:30. So this would be a good time to use the bathroom. Stretch your legs, please. Please get up and stretch your legs. It makes a difference for a long class.
You really don't keep being obsessed with what you're being obsessed with.
Exactly. Which is really hard with this stuff. There'll be times I'll be sitting in front of the computer for hours and it's like you get up and it's like having been on a plane and you're wobbling around. It's good for your brain. Get circulation going. Get food, please, too, if you need it, or grab water, coffee.
Oh yeah, there are still some eggs that I brought in the kitchen.
Really?
Because
Want to go see the egg stash?
that's gonna be difficult.
Oh, I see.
I tried to import ramen, but
Oh, my. That's fun.
this is out of some place that has like
Nice.
nice.
Love to see that ball.
This is I'm gonna put the ball in there.
See what happens. Yeah, it's interesting.
If I don't have it, that's even better.
Well, yeah, with power and the stuff that's out there, you're probably because we're doing this, mesh. So it's gonna look at that hard path. Although, you know what, experiment with it, let's see what happens. People standing up and walking away from the computer is very difficult. Pretty warm. So are you enjoying this or is it like super big? Totally different. Yeah, totally. Right. Oh, I mean, this is all, like, I've supervised people using my apps, like, screen hands-on. And usually I always, like, half a dozen times I try to get into it. I'm going
With the material, where's the apply? When you're like,
You just drag and drop in material.
and then it applies itself, so I don't have to hit anything else.
Mm-mm.
Oh, that's cool. I got
Yeah,
it.
yeah.
Okay, cool.
Yeah, really pretty easy.
Yeah. Well. Anyways, I don't want to gossip. But. But I really want.
Right, I knew you brought it to me, but I thought
I actually